All right. Good afternoon, good morning, good evening, wherever you might be. Welcome, everybody, to this FlexoKite webinar on white ink and flexible packaging. What you see on the slide are just a little logistics about the webinar itself. Everyone's automatically on mute. And we can answer questions at the end. You can also type a question in during the webinar anytime, no problem. If you look on the right-hand side of your screen, you'll see the questions, and also for the polls. We'll have some polls coming up in the webinar. Everything's being recorded, so you'll get an email within about 24 hours, so you can download and actually watch the recording if you want to go back over it. And if you have any audio or video issues during the webinar, it's best to just refresh the browser. So let's get started. So this is the first technical webinar we're bringing from FlexoKite. Kind of exciting. We had a webinar in November of last year to kind of announce FlexoKite and the concept. But just for the people who weren't able to actually follow that, what we've created are two demo centers, one in the Netherlands and one in India, that are fully equipped to be able to show people a complete demo from PDF to print. We have a complete software there for pre-press, plate making with solvent and thermal processing. We also, later on this year, will be having a box press coming into the site in India to be able to use, where we can give people more education about anilox and print supports. We can give them more technology info on different products or different techniques, and then demos and training. So let's get started with why we're here today. It's to really talk about white ink. And what we're going to go through are like 5 basic parts. One is to look at the role and the impact of white ink in flexible packaging. The second is to look at evaluating white ink. So when you actually look at the print results, how do we try and really evaluate that and make sure we're getting the real result we want to have and the customer requires? We'll have a look at some adjustments you can make in production, and also have a look at what those trade-offs might be in terms of efficiency or cost. Then we'll go through the technology options that you see coming out today to help improve the white ink quality. And then lastly, we're going to round off with some information about a customer testimonial. So somebody who's actually been doing some real work and give you the results and the data coming from that. So when you start to look at white ink, it's really a critical part in flexible packaging. And depending on the type of work that you're doing, the result you need really varies, because there's a wide usage of white in flexible packaging. So in some cases, you might have a bread bag where the quality of the white is not so critical and the customer is not so demanding. But you might have other products like washing products or diapers or something like that, where the quality of that white can really influence the actual quality that we see in the end product. And there we see customers being very, very critical about what that end result needs to be. And of course, everyone's biggest nightmare is if you're making multi-packs, that when they go to actually scan that in a retail environment, that they don't scan the barcode for the multi-pack, but they actually scan one of the barcodes inside. When you look at white ink itself, it's really probably the least expensive ink that a converter buys based on the kilo price, but it can actually be one of the most expensive costs in the production of everything. And that's just because of the amount of volume that has to get used. And what we see is that on average, a single wide web flexible packaging press in full production over the course of the year will probably have around 1 million euros worth of ink usage per year. When you start to look at the white and pull that out, that what you see is the white ink usage could on average be about 25 to 30% of their total ink usage. So that comes out to really maybe around 300,000 euros per year per press, which is a big spend. So it's important to take a look at it and say, when we look at this expenditure we have, how can we optimize that? How can we really get the best potential quality and efficiency out of that part of our production. So this is where we're going to go to the first poll question, because it's interesting to try and get an idea for people. What are the requirements you see coming from your customers? And again, you might have different types of production that you're running, so maybe you have some slightly different opacity levels. But it'd be great for people to kind of fill in here. What do you see as the typical opacity requirements that you see coming from customers? So we'll give everyone a couple minutes to try and fill that in. So interesting, what you see now coming in is, for the majority of people, the requested or required opacity is 55 to 60%, which is really very high. It's higher than I would have expected, but really interesting. And then you see it split between 50 to 54%. No one trying to go below 50 is what they're aiming, a few coming in. And then for some people, they don't have a specified opacity level that they try and hit. Really interesting to kind of see that. So what we're going to do now is I'm going to hand over to Mr. Robert Bruce, who's going to take you guys through the next little part about evaluating white ink. Robert, over to you. You're on mute, Rob.
So thanks, Dan. So quickly to introduce myself. Yeah, Robert Bruce. I'm one of the Flexo product managers at ESCO, and just to run through a few slides here on evaluating white ink. So when evaluating white ink, opacity is king. Yeah, I've been fortunate enough to work in the Flexo industry for the past 30 years, and throughout that term, everybody has always spoke about opacity as the leading metric for evaluating white ink. And typically nowadays, we'll see printers with a tool like the X-Rite Exact by the side of a press with an Lanetta card. And it's quite simple and quick and easy to calculate your opacity. Common alternative, if you're lucky to have one, maybe stuck in the back of the factory in the QA department, is a true opacity meter. But yeah, not always a friend of the printer, as he has to pick up his sample and go and travel and go and find that thing. But really the question that I wanted to ask is, does opacity alone give all the information that we need with regards to white ink? So just want to go through the next couple of slides to maybe add a couple more pillars to this story. So the first pillar is ink laydown or ink quality. And certainly at ESCO, and the more I talk to people about ink quality, we all seem to be using this term mottle. So what is mottle? You can see what mottle is on the image on the top left-hand corner there, where you see some voids or where the ink isn't performing as well as what it should be. And to support this particular issue in the marketplace, we now see some new electronic tools coming out onto the marketplace. These digital capture devices, where they basically take a photograph and then use an internal algorithm to take a look at the black and the white and give you some sort of numerical value behind what that mottle factor is. If you don't have one of these latest pieces of technology, then you still see quite a lot of people with a good old-fashioned loupe using their experience and their eye to determine what that quality should be. And if you're not achieving that quality, then it's really interesting to understand what do you actually do with that. So the next pillar that I want to talk about is ink weight. And this is a really important metric, as it's an indicator or a leading indicator of how much money you're actually spending on your white ink. So again, there are a few methods of calculating ink weight. What we see a lot at flexible packaging printers is they'll have some form of high quality scales where they're measuring the unprinted film weight against the printed film weight, trying to take lots and lots of measurements there. But that in itself isn't an exact science, and how you cut and how you weigh can skew those results a little bit. But with these particular issues, what people tend to do here is run different weights of anilox to overcome these issues. And when they're doing that, then it's not easy to calculate what your end cost for that piece of packaging is going to be. So to sum up, when we look at this combination, these three pillars of opacity, quality, and ink weight, we can really start to define the quality and how much money we're spending. And Nick, over to you, sir.
Okay, thank you. Okay, just a brief introduction. I'm Nick Harvey, Technical Director for Apex International. This section is dedicated to the current options available in the industry that you're all probably aware of to achieve higher opacity. And it also looks at the implications and that it can have on all aspects of ink laydown right through to press performance. So, as Rob said already, the easiest and quickest is to just throw on an anilox roll with a higher volume, a different screening, but basically lower screen count and a higher volume, which will invariably do the job of giving you a higher opacity. The negative from that is a higher volume, coarser anilox requires more cleaning. Naturally, it can mean that you need to reduce the press speed for the drying capabilities so that the next color can print on top. You need maybe to increase the airflow and the drying temperature, and of course it increases the ink usage and you get a heavier product. Okay, second option out there is you can look at higher opacity white ink. They are out there in the marketplace. In order to get a higher opacity, you need higher pigment or a higher level of pigment within the ink, and this also comes at an additional cost and will also give an additional weight to the product. Also, a consideration is that most of you will recognize that the white ink is the most aggressive within the printing process. And if we look at the Dr. Blade, your white Dr. Blade is always worn faster and quicker than your other ones, partly because of the anilox, partly because of the pigmentation of the ink. When you go to the higher opacity pigmentation with the ink, there is also a risk that there'll be more friction between the blade and the anilox, creating faster wear. We then have a third option, which is in the marketplace, where you can make a double hit of white. Yeah, effectively you just make two prints. This takes up 2 print units, and in some cases even requires the third station, which is the next one, to be left free to ensure that the ink is fully dried. Plus, the additional white unit requires an extensive washdown of all pipework, Dr. Blade chamber, and the pumps. If it isn't perfectly clean, then you will get a compromised color in the white, so that obviously adds extra time. It also is a big extra use in ink, and again, heavier product, more to transport. Then there is also the increasing the hardness of the mounting tape. This will reduce the compression and helps reduce the pinholes. However, as a direct consequence, this can increase design bounce. This will create additional downtime, slower press speeds, increased doctor blade pressure, which means increased doctor blade wear. So again, these are the trade-offs that you have to deal with every day, and the technologies that are in the marketplace.
Okay, so now we come on to the second poll question, which is curious to see what's your go-to solution when you're in production and you're needing to increase the white or improve your white? Is that going to a higher volume anilox, going to a harder tape, maybe even going to a different plate or a different surface pattern? Obviously, you know, during production, you can change the anilox. You could take the plate off and put on a different tape. But it's not so easy during production to actually go to a different plate unless you have that already ready, or use some different surface patterns. You know, you kind of need to plan that up front, what you want to be able to do. So interesting here, a lot of people looking at changing the patterns they have on the surface of the plate, and the other ones mostly going to a higher volume anilox, which I think is logical because, you know, if you're going to move to a different surface pattern, then you're going to have to pull the job and put that back on at another time. But learning about what's happening in the production will definitely help for future jobs. All right, then we'll move on to our next section. We'll talk about different possibilities in the surface screening.
So that was a nice segue. So it's interested in the poll that people are looking at using different surface screens to try and influence, and also the anilox, the two main topics there. So I'm going to share the next few slides with myself and Nick, and first of all, look at this whole dynamic of surface screens. So it's an interesting option, as the audience have already said, that you know, plate surface screens can change the characteristics of the plate, but plates can come from different sources, and typically the flexible packaging market is serviced by pre-media companies or trade shops who supply plates. So let's just take a couple of slides here to look at this dynamic between the trade shop and the printer. So from a trade shop perspective, the trade shop really needs to have different solutions for different printing conditions. So trade shops may be working with 10, 20 or 100 different printers and need to be able to offer different types of improvements based on these different environments. So as we're already aware, you know, there are screening options available that have the capacity and capability to fine-tune these plates for these multiple different configurations. So it's a great tool for the trade shop to have. It's also important to understand that each anilox and press can perform slightly differently in relation to the benefits of the surface screening. So for instance is the guy who's using a 100 LPI with a 10 volume anilox, he will have a different result to the guy who's printed with a 500 LPI 7 volume anilox. For the converter, it's a slightly different dynamic. So here we're showing a scenario where the printer has maybe got 3 presses, but this printer needs to have the flexibility within his company to move jobs from press to press to ensure that they're manufactured in the most efficient way. So therefore, having different white plates with different patterns doesn't always make sense and doesn't always give you the ability to achieve your goals of optimizing your white ink. So if you don't have some sort of anilox standardization in place, then this leads us on to the next topic. So now I'll hand you back to Nick, where we can take a closer look at how we can look to harmonize and synchronize those surface screens with the anilox roller. So Nick, back over to you.
Okay, thanks. Yeah, following on from Rob, as a converter, you need to have the flexibility within your company to move jobs from press to press. That's the standard. To have a dedicated white plate with a dedicated press and a specific anilox can be impractical and inefficient. As we just heard, there are a range of surface patterns that can suit a range of anilox configurations. However, to add to the complication, the micro screening options are not married to just the volume, but also to the LPI or lines per centimeter of that anilox. To put that into perspective, we know as an anilox manufacturer that there are many forms of cell engravings on the market, from H60 to various exotic screening cells. And they will allow you, for example, to produce a 10 centimeters cubed meter squared volume, which is 6.5 BCM. And you can make that from a screen ruling or a spread between 70 lines per centimeter, which is 180 lines per inch, right up to 270 lines per centimeter, which is around 700 lines per inch. So you've got, with that volume, all of those options to achieve that 10 cubic centimeters as a volume, which just amplifies the level of complexity for a converter or a print group. So on to a couple of slides on GTT. GTT engraving, by its design, does two things. Firstly, GTT has a fixed opening and depth for a volume, meaning that repeatability and standardization is fixed and much easier controlled. A 10 volume has the same opening wherever you order it from and whenever you get that into your production. It needs to be noted that the dynamic of the curve, the depth and the opening have been optimized with the 2.0 series for the best anilox performance. Secondly, GTT will not allow air to be dragged into the chamber, ensuring a calm surface for the print plate to receive the ink from. The images you see on screen are just visual to take it into a more perspective. With the standardization, consistency and calm performance, this provides a stable foundation that is ideal for the plate surface screening to be maximized and also be used across multiple platforms or multiple presses. This gives you less plate wear, which we'll come on to, and really makes the plate screening option much more viable for you as a converter. Oh, you're on mute, Dan. Are you? Oh no, next one is. How does GTT eliminate the air? In short, air will never enter into a positive pressure environment unless it is trapped and forced. A better explanation of this is in the following short video. If you could play that.
The white ink dilemma. Optimizing the efficiency and quality of your printing operations can be a challenge. White opacity, print quality, and profit are all critical for success, but maximizing all three can be difficult. Printed packaging is not purchased by a fixed cost on ink usage. Therefore, applying excessive ink is effectively throwing money down the drain. Instead, leverage the savings possible with GTT 2.0, the anilox that pays for itself. White ink usage is approximately 30% of your total ink expense. Focusing on ink usage will allow you to achieve the required white opacity using the minimum amount of ink and maximize profits. High white opacity directly impacts the overall quality, enhancing the printed image fidelity and creating a blockout for multi-pack wrapping, eliminating the risk of a cashier scanning an individual product barcode. Numerous methods exist to achieve higher opacity. However, each solution results in a trade-off between opacity, quality, and profitability. Higher anilox volume, a double hit of white, microstructures on the plate, and harder mounting tape all increase opacity. Unfortunately, they can lead to less color options on press, higher ink cost, slower press speed, and increased waste. The new GTT 2.0 eliminates such trade-offs and is already proven in real production orders with run lengths of over 160,000 linear print meters. GTT 2.0 offers printers the enviable options of achieving the same opacity with the benefit of up to 24% white ink savings, or increasing the opacity they currently achieve by up to 14%, improving print quality and blockout, and still saving up to 4% on white ink costs. Both options are also better for the environment with less ink, less energy, and less total order weight, reducing transport costs. So how does GTT 2.0 work? With any form of closed cell engraving, the anilox rotates through the positive pressure environment of the ink-filled doctor blade chamber. The anilox then applies the ink to the contact area of the raised plate surface. Once ink is transferred to the plate, the anilox cells naturally fill with air. With the high speed of the anilox's rotation combined with the cell's enclosure, the air is dragged into the doctor blade chamber. The rapidly rotating anilox creates a washing machine effect inside the chamber, and air within the chamber cannot be dispersed. This creates microbubbles within the ink as the anilox cells are refilled with both air and ink. This creates two problems. First, the ink delivered to the plate includes air that will create pinholes in the print. Second, as the anilox cells pass under the doctor blade, the air is compressed. This air then expands as cells leave the chamber, making the anilox surface appear turbulent. These microbubbles and air compression and subsequent air expansion results in pinholes in white ink laydown. GTT 2.0 eliminates ink aeration with its patented open wave construction, which never traps air. This ensures not only smoother, more compact, and more opaque laydown, but higher opacity with less ink, saving you significant amounts of money. The patented GTT engraving continues to evolve and improve, setting the trend for the industry. Available from any of Apex's 5 production facilities and manufactured and supported locally from a strong global organization, GTT 2.0 is truly the choice for opacity, quality, and savings. To learn more about the customer trial, contact marketing at apex-europe.com for the white paper. The easiest decision you will ever make. GTT 2.0. More than just an anilox.
Okay. We'll now jump back. I've got a bit of an echo there.
That's right. So the next thing is move on to the poll question number 3. You just get an idea, what are the volumes that you typically use when you're running production? I'm sure you have a variety of different ones, especially if you're doing a double hit. Most people will have slightly different volumes when they're running to print a double hit. Definitely the trend is for the much higher volume analoxes, I guess. Nothing surprising there for people able to hit higher quality packaging and get that opacity that the customers really require. No, actually, quite a mix. All right, now we're going to move on to the next part, which is a testimonial. And Nick, why don't you take us through that?
Okay, so far we've focused on theory and logic. And what we want to show you now is that we've validated this with real live production orders in wide web Flexo. So we started a project that was led by Caveris in Austria, Mr. Klaus Berger, head of print. The project was to assess the influence of 4 different anilox engravings, focusing on the following key assessment parameters. A, the opacity level, obviously that's key. Ink consumption, so the project was set to measure this. The impression settings on the press, which were obviously digitally recorded, and also plate cleaning throughout the production run. Full production orders were run and produced where only the parameter to change, the only parameter to change was the anilox. All the other parameters remained exactly the same. Sorry, can you go back down? Okay. The results were controlled and assessed by Caveris in conjunction with Apex, Mr. Christian Hoof. The conclusion was that GTT engraving required less impression between the anilox and the plate. This was recorded in the increments on the control panel. This will also reduce plate wear for obvious reasons. And at the same time, it reduced the ink buildup on the edges of the plate, as you might be able to see from those images, which in turn will reduce the need to stop the press for plate cleaning. The physical ink saving was qualified and controlled by the project team at all stages during the 160,000 meter production run. The ink savings were significant, with 24% saving on the ink usage while achieving the same opacity. You can request the white paper on this project from the contact shown at the end of this webinar. So left with me to summarize the webinar. You'll have heard a lot of data today. Some things you will have already known for sure. Hopefully there's elements in there that's provoked a different thought. What I want to say is the future of Flexo is more than just a single product. It's about a total solution. What you get from Flexo Kite is we offer the industry the opportunity to find the best recipe or cocktail of process parameters that not only achieve a quality goal, but also tick all the boxes for efficiency, repeatability, reliability in the most cost-effective way. With that said, I'll hand back to Mr. Dan Pulling for the questions and closing of the session.
All right, sorry about that. My PowerPoint seemed to take on a life of its own and kept wanting to just move forward. So now we can actually move on to some real questions from everybody. We already have quite a few in there, so I'll start to read some of these out. And in the meantime, I'll just go to the next thing. If you want some more information about what you've already seen today, you have some contact details here. There's a couple of people have already asked in the questions. You will get an email within the next 24 hours for a recording to be able to download it, so don't worry. That's definitely coming. I'm just going to run back through some of these questions. One at the very beginning, I just wanted to share. Larry Goldberg had said that the FTA recently completed a white ink opacity measuring study. That could be really interesting for people to look at, how people go about actually measuring and checking the white opacity and the quality for that. Like I said, we've seen some new devices now that actually can take a picture of the white and try and evaluate what's the model that's in there, because that's really the pinholing that you see. So that can be another key factor in what you see in the final result, because we really see now, looking at white, it's more than just the opacity itself. There's a question for you, Rob, here. For what kind of modifications did ESCO make in order to get a plate with a better ink transfer?
Yeah, thanks for the question. Yeah, we sort of tried to avoid talking about some of the product in detail, but in terms of what we did, So we basically took 4 or 5 different plate types, tested that on a few different substrates, different combinations of ink and anilox volumes. And what we did is we looked and evaluated which screening patterns were working best on different conditions. And what we're left with is, I think, what was shown on the on one of the slides there, where we have 8 different surface screens now for white ink. And what you'll find is, depending on the volume and the LPI of your anilox, you'll see that some of those patterns work better in a very high volume environment, so that the 100 LPI, 15 volume, versus the low end of the spectrum, sort of a 6 volume, maybe a 500 LPI, and everything in between. And also working with the major plate suppliers, DuPont and McDermott. So basically what we did was a lot of background work, thousands upon thousands of measurements and screen captures to try and assess which patterns work best. So when it comes to implementing white ink projects, we try and take away a lot of the pain associated with this type of research. Hope that answers the question, by the way. And if it doesn't, then please feel free to reach out.
And Nick, there's a question here for you. I think that's best is why would you select analogs with a thinner wall and a better ratio for the volume and the cell count? Can you give some more insight there, Nick?
A thinner wall, you say? Yep. Yeah, I think the risk of understanding that the anilox only contacts 2 things. One's liquid, which is the ink. 3 things, in fact. One's liquid, which is the ink. One is the plate, and the other is the doctor blade. Now, the plate is a soft polymer. That's not going to have any impact on the anilox and its performance. The doctor blade is the thing that scrapes and sits over the surface of it. When you look at choosing your anilox, and that's one thing that Apex does, that we put in place, is that there are many extreme specs on the market. If you wanted to drill or laser engrave a hole completely through the anilox, we can. Totally pointless, but you can. It's like this. So we control or advise never to go too extreme or have too finer cell walls, because that then downstream creates less life for the anilox. Is an expensive part of tooling for the machine. And secondly, when you look at that friction, the doctor blade sitting across the surface of it, the friction on the side walls of the anilox in the rotating direction is less than the ones that are at the bottom and the top. If you've got that doctor blade scraping across the surface of the anilox at the apex peak, if you like, and at the bottom, then there will always be more friction and more potential wear in these areas. What you get with the GTT is we've taken those areas out. So our wall isn't exactly thinner. There's less walls for sure, but the walls are strong, the walls are structured, and we don't have the weak points of this horizontal or angled horizontal cell walls. So we would never advocate going to paper thin cell walls. We would never advise that. GTT isn't that, and it's important to understand that that's the case. I hope that explains a little.
Yeah, there was also a question about what would be the best volume for the analogs, but I think that's going to be really a combination of the plates, if you're using a surface pattern, and the opacity requirement that you need to get for the customer, right?
Yeah, I think you've got to look at what's best. The best for the printer and the converter is 2 cubic centimeters volume, because he's going to use almost zero or very little ink, but it's going to fail in the other areas. And that comes back to the point of understanding the opacity that is required for the product. and then fine-tuning the plate screening, the plate, the anilox with the ink, and making sure that they marry together and are practical for your company, because in the end it's all about ink weight. You know, the more ink weight you put down, the more it's costing you. That's just the general fact and the theme of this thing. And I tried to sum up in the end that it's not. Yes, there is individual products on the market, but in the end, the solution is what's needed, not just the single product. So that combination and working together as suppliers is will determine what is best. In other words, what does the customer want, and how can we achieve that together collectively? I think that's the theme.
Somebody asked us a question about what's the difference between the GTT and the GTT 2.0.
We've done a lot. Yeah, we've done a lot of work. It's something that's, you know, it's fair to say that we could have relaunched GTT probably 6 times over the last 10 years. We haven't gone down the marketing aspect of doing every time we've done a tweak or a change. We've quietly been in the background innovating and developing to get something that is that wins for all industries. And it's quite clear that there isn't a one size fits all, or one fix is for all market segments. You know, we do offset coating, we do corrugated, we do wide web, we do label. So what we've been able to do over the time is manipulate and innovate the engraving so that it delivers. You know, we're after a kiss touch on the surface of the anilox, and if we can get that through the transfer without excess pressure, that's where we see the benefits. And I think, just to elaborate a little more on that, is the anilox and the plate never run one-to-one. No, they're very, very close, but never one-to-one, because that's the dynamic of transferring the ink. If you have the top and the bottom with cell walls, you are basically grating like a cheese grater the plate all the time in production, which is why the leading edge generally gets more worn than the rest of it. And part of the development, part of the innovation, was looking at that aspect and creating a patterning and a screening that didn't wear that plate as much. And that's basically just innovation that we've done. And GTT 2.0 is a step change. There is no question. There definitely is a step change.
And Rob, a question for you: are the patterns that you were showing today, are those available in the Print Control Wizard for flexibles?
Yeah, they are. Yeah, they're available in 2 products. So we have a Print Control Wizard pre-media, which includes all of the screens, and then a Print Control Wizard for flexible packaging, if that's just what you focus on as a plate making operation. And in both of those pieces of software, in our 20.0 version, you can get access to these screens.
Then there's another question: is there a calculator that ESCO has to determine the best pattern without actually printing that test pattern?
Yeah, I think that would be the utopian position, wouldn't it? Being able to predict what's going to happen on a press without doing any optimization work. I would say at this moment in time, no, but certainly forums like Flexokite, you know, where we want to try and build some of these standards together. You know, maybe we could take 2 or 3 components and give you a quick snapshot as to some settings, but in a wider context, you know, there's so many variables out there, which is part of the beauty of the flexo industry. But in some instances, yeah, it does hold us back somewhat. So I would say, with the work that we've done so far, we've been able to round down surface screens as a topic down to 8 screens for the thousands of different combinations of analogs that you can get in terms of volume and LPI. Is there an opportunity to go further? Potentially, but I think it's going to be down to these types of partnerships like Flexokite where we can maybe look to drive them. But yeah, I'd be interested to continue that conversation with you to fully understand what your expectations would be there.
And Nick, there's a question here about how did the calculator quantify the ink savings from the Covaris trial, or is that more data that's available in that white paper that's going to be available?
Yeah, it's very much in the white paper. All the data's there. It's clear the design that was being printed. It was a real production run, and this was a Covaris project, and we supported it as a supplier, and we didn't influence the results at all. They've got very good process control of ink to press and ink back from press, viscosity. All of the dynamics were very, very controlled, and that's all within the white paper.
And then another question here, probably for you, Nick. What would you suggest for printing white on a high speed press that's that to reduce these? I think it's dust generated in the print.
Misting.
So probably misting, yeah.
Yeah, that's an interesting question. It's obviously some presses are getting faster and faster. We did actually do again an innovation test and trial with a large OEM. I won't mention it, but it's one of the largest based on evaluating different forms of the GTT engraving. And we managed to run an engraving up to 600 meters per minute, not with any misting. It also didn't have any density drop down. It was very controlled, very consistent. I think when you look at the misting, it's basically little tiny pigments being shaved because of the speed of the press. So when I explain the lift out of the cells, that lift, obviously, the faster you go is greater, and then when it comes back around to the doctor blade, it kind of underneath to go back in, you get this shave and this mist occurs. What I will say is, to be transparent, the first version of GTT that we put into a printer, that ended up like gorillas in the mist. The whole factory was covered with mist, and you learn and you go through these procedures, and again, coming back to understanding that label production is different than wide web and corrugated. UV ink is different than solvent or water based, and understanding those parameters have enabled us to move the technology forward. And like we said, it's time now to have a rebranding of it. But for me, from my experience, GTT specified for high speed, we have a solution. If you look at conventionals, again, you'll find that it is more apparent on the higher volume anilox rolls for 60 degree, even more apparent on some exotic cells like long cells, and it's all to do with that ink rivering up the back. And happy to take the discussion offline if that's necessary.
And then there's another question that's probably for both of you, I think, and that's looking at the volume that you have with GTT and how do you combine that with the plate technology and the patterning to get those two aligned as best as you could.
Yeah, I can maybe take the first part of that, Nick. So from a screening perspective, I think I mentioned beforehand, and also the illustration in the PowerPoint, that we have these 8 patterns which have been rounded down from hundreds of different options that we have. And we look at pairing those individual patterns with different volumes and LPIs of ink. So that's the theory from a screening perspective. From Nick's perspective, I'll let you talk about the anilox side, mate.
Yeah, sure. I mean, again, it's a true partnership to get to the right results. It's understanding where that difference is between a 200 lines per inch and a 240 lines per inch, with both with an 8 volume, and the same with the difference between an 8 volume and a 6 volume. There is a different screen pattern for the plates, as Rob explained, that will better suit and be more effective in relation to one of those engravings or others. The complexity comes, as I said in the presentation, that there is so many different specs to choose from that it's almost a moving target for this plate screening to be effective. And what we hope to do, and we will do moving forward, is create some kind of internal project that we can assess with different anilox rolls or banded anilox rolls with all the patterns that Rob can provide, and we should be able to get a best guess isn't the right phrase, but the best calculated screen for that particular anilox. But again,
yeah, we could maybe put some sort of based on some work that we could do, like you say. So if we work with all the different engravings within the GTT range, we can apply those screen patterns to them, and then we can build some sort of matrix in terms of what type of opacity that you could look to achieve with those combinations. I think that may well answer quite a few of the questions that we've got from the back of this webinar, where people are asking a lot of things about which tape, which anilox does this, what plate does that, and I think maybe some simplification of that process could help some of the people on the webinar.
Then there's another question here. How will you actually calculate the real ink transfer in percentage on the printed material?
Well, you'll get that in the white paper. This isn't a calculation of theoretical volumes that have been sent through. This is physical ink weight on large production runs. So the ink is very controlled and within the process, which is explained in that white paper. And this is where you see the notable differences that were qualified and quantified. So this is, as Rob said, to measure print film weight in a 10 centimeter square, and then measure a printed sample with that's fraught with danger of being accurate, because your film thickness can vary 1 or 2 microns from the one that you're taking as the blank to the one that's got ink on. And there's ways where you clean off the white and then do it again, but you're also it's not perfect solution. What we've got is actual longevity of a print run, and their physical weight, which was very, very controlled in its manner, and there are the results. So
Then another question here about the best way to measure opacity on aluminum foil.
Over to you, Rob.
Well, it's not any of the methods that I just spoke about, because I was talking about opacity meters and being able to measure through the film. I'm sure that maybe my colleagues at X-Rite have some spherical spectros which are used in the can industry. Whether that measures the actual opacity of the white, I don't know, but if we take that particular question, and I'll go and ask my friends at X-Rite.
We'll try and get back to you on that. I can tell you also, from a color perspective, being able to measure on aluminum is virtually impossible even if you just wanted to measure color or density, just because of the reflection that you get coming back from the foil. Extremely challenging.
Yeah, I think that's where these different spectros with the spherical head come into play. So there are devices available, but they're not the typical machines that you would get, stuck by the side of the press like an Exact, which, as you say, Dan, all works on reflection.
All right, guys. Thanks very much for all the questions. Definitely very interesting for us to see the feedback in all the polls. And I think we're about ready to round it up here.
Okay. Thank you very much, everybody, for attending. Cheers. Thank you.
Yeah, likewise. Thank you. I think we'll assess the questions as Dan said, and we'll try and answer those individually back outside of the webinar, so that no questions lost.
Indeed.
Okay. Have yourselves a good evening or a good morning or a good afternoon, wherever you are in the world. And yeah, thanks for listening.
Okay.
And
Bye-bye.
stay safe.